the transition from product to infrastructure. So this is a talk about how my understanding of software delivery has changed throughout the past number of years. Basically because I've moved from being a product developer, so just working on code, to an actual infrastructure developer. People do like to call me a SysAdmin. I'm not a SysAdmin. I actually write code, and I don't just look after servers. So a quick poll, any developers? QAs? Business people? So like product owners, stuff like that? Okay, cool. So this session is very much how to bring all of those groups together in order to build the best software you can. Okay, so my name's Paul Stack. My contact details are down here on the left. I'm very bad at email, so if you want to get in contact about my session, tweet me. It's by far the easiest way to get in contact. I'm an infrastructure engineer. Okay, I actually maintain, manage, and program everything to do with infrastructure in my company. Okay, so that's not actually, as I say, racking and stacking. It's much more software related because everything I do is automated. It has to be automated. I'm a reformed ASP.NET and C# developer. Any C# developers in here? Yeah, I used to love C#. Then I found that I needed to start automating Windows, and it was awful. I'm a DevOps extremist. I absolutely love everything to do with DevOps. Okay, I follow a lot of the talks. I follow a lot of the principles and practices, and I try and apply those on a day-to-day basis in order to bring everyone in my company together. And lastly, I'm a conference junkie. So this is my 10th conference this year. Speaking at, and I have 4 more to go after this between now and Christmas. So I'm going to make a general sweeping statement. Being a software engineer is easy. It is, right? So the typical journey for software development and for product is as follows. Somebody has an idea, okay? Whether that's an app, a website, whether they need to build something in-house. It can be due to market research or customer feedback or just a plain hunch. Okay, somebody thinks that there's a gap in the market for them. Okay, number 2, requirements are gathered. So some people sit around a table, they discuss what the app has to do, what they have to build. Then development happens. We all know what happens during development. And probably somebody sets a release date at this point, a go live date. Okay. Number 4, testing and feedback happens because obviously everything has to be tested, thanks to the lovely QA people, because otherwise we wouldn't find anything without them. And then we probably reach our definition of done. Hands up who has a definition of done. So everybody's definition of done is completely different. Okay. It ranges from when the product's in production, or when they're finished their development cycle. There's a company, an international company called Yelp. Yelp do a lot of reviews, and you can do bookings and reservations, etc. through them. And Yelp actually have pictures all around their offices. Their definition of done is when the software is in production and it has monitored, it's being monitored by their system, okay? Which is a good definition of done. My definition of done is when the software is deprecated. Has anybody in here ever been involved in a project where they've taken a system out of production? Oh, 1. So, and this is generally what happens in software. Okay, what we do is we build systems and we put them into production and we forget about them. And where infrastructure engineers come in and where the newer age of ops come in is actually maintaining those systems while they're in production. All software should have a lifespan. It has to. Backwards compatibility is the devil. Has anyone actually ever tried to maintain a web application for IE8 or IE7 or IE6? It's horrid. It's absolutely horrible. You have to actually have a shelf life on your systems so that they evolve. But one thing that I really want people to take away from this talk today is that the actual creation of the software is only just the beginning. The code itself is probably 10% of everything how the software works. Okay, as we've seen from the straw poll, we have QA people, we have business people, we have devs, we have ops, we have marketing. We have all of these different people who are involved in actually making your product. When software goes into production, we actually find out more about the software than we can ever imagine. Users interact with our systems in ways that we can't even predict. And they will find bugs, and they will find pathways through our systems that we have not tested. So it's important that we have the correct feedback mechanisms and the correct ways of dealing with that, and not just create some code, throw it into production, and forget about it, because we don't know how it's going to react there. There's a really good quote from 2011, which has stuck with me forever, and it's actually, I use the same quote in the next talk that I do as well. Okay, just because it's so poignant. Until your pretty code is in production, making money, or doing whatever it does, you've just wasted your time. And it's by Chris Reed. Okay, Chris Reed used to work for ThoughtWorks, who are a worldwide consultancy company, and he's now working for a company in the US. And this is probably one of the best statements that I can ever sum up what software delivery is. It's all about getting your systems to production and working out what the value of that software is. Craftsmanship movement is fantastic. TDD is fantastic. But there has to be a line drawn that we actually ship our software. We can't just find new bugs and then go, oh, we'll delay, and we'll delay, and we'll delay. We get it out, we fix it, we iterate on it, we learn while it's in production. So how does your code get to users? Software delivery, the actual release mechanism itself is a skill. There is a brand of, or a sect of people in IT called release engineers. Okay, and I actually used to not understand what release engineering was. I used to sit there and think, there's no way that these people can just be sitting deploying code all day long. Because that's what I thought release engineering is, but that's not, it's actually a skill. Let's talk about this, okay? So I worked for a company, a large multinational company, up until April passed, and I was there for 4 years. When I joined the company, software delivery happened every 5 weeks. Okay, it was 4 weeks worth of code released in a 5-week cadence, because every team had their own release branch. Okay, we used SVN, which is not a problem. Okay. We weren't using SVN in its own, in the correct way that a version control system should be working. So teams of 10 would have their own branch, and they would work in that branch for a month. And at the end of that month, we had what's called merge week. And it actually was a week. Okay? It took a week, and there were chains of emails going back and forward throughout the engineering team, trying to tell people that you go first, then you go, then you go, then you go, then you go. And if you were first to merge your code into the trunk, the world was okay. If you were the 9th team on that list, your world was hell. Absolute hell. And throughout, my job at that company was to basically facilitate better software delivery. And the CTO came to me and he said, right, how can we make this better? You know, releasing code every 5 weeks is pretty bad for the type of industry we're in, because we're playing catch up all the time. And in the 4 years, it took 4 years, but we went from releasing one system every 5 weeks, and I think we got to 25 to 30 deploys a day when I left the company. Okay. And that's a lot of iterative getting better and learning from things, and a lot of my next talk is actually about that and about how to bring those practices in. But it's all about understanding how to release software. Who likes releasing software? Who gets scared when releasing software? And that's what happens in our industry. We get scared of it because we've probably been in a situation where when we've released it, it's gone wrong. And we've had a pretty horrible time trying to fix it when it's in production. Or what's actually happened in some cases is we've just given up and just rolled back. This has happened to us all. And we have this myth in the industry that delivery is hard. It's not. It's not. Delivery is not the #1 priority of the average developer. Now, when I say average developer, I don't mean like the mid-tier developer not making themselves better. I mean, as a sweeping generalization, 99% of developers don't really bother too much about the delivery process. There are a number of people who are just keen and interested and make themselves want to be better at the actual delivering of software, but generally speaking, you only get a couple of those in every company. Not everybody's bothered. But this is a huge revelation. This is something that may seem obvious, but as I was getting into software, it's not something that I ever understood. And it's not something I actually thought was an important fact. But the more I've gone through this journey of transitioning from the development side into the operation side, the more I've realized that this is probably the most important thing. Not enough of us care about releasing our software. So there's a very good question that Mary Poppendijk, who's a very famous lady in the Agile world, has asked. Okay, and she basically says, how long would it take your organization to deploy a change that involved a single line of code, and can you do this on a reliable, repeatable basis? Does anybody want to volunteer and tell me how they can do that in their company? No? So the outcome is generally one of two ways. The first one, if it's a bug, we can do it in one way. And we can take some, maybe minutes, hours, or a day. Okay? And that's because it's a bug. But then the other way is that for normal development time, it maybe takes us a couple of weeks. Okay? So my question to you is, why do you treat bugs differently than you do normal development? Because it's still development. They still have to follow the same pipeline, and they still have to follow the same methodology. When it's a bug, you've probably, if it's gone from weeks to days, you've probably skipped a lot of the steps. So it's better to not do that. It's better to actually follow the same process, but take your process down to be a little bit faster. We call this cycle time, okay? And it's defined as the total time from when the beginning of the work happens to actually when it's finished, okay? And you can measure it. Some of these slides are in my next talk as well, so if you can probably skip the talk if you've seen this. But you can basically measure it and see that you can work out the time taken at each step. Okay? And this is how I took our software development time down. This is actually the cycle time graph that I drew for the CTO, and I showed him, and I said, this is what happens when we go through a change. And his question to me were, why are we waiting for 19 and a half days? That's 19 and a half work days. That's a month. That's where our month went, on waste. Because we could actually see at every single point the problems in which software was just lying around, waiting to be gone through another part of the process. And my job over the 4 years was to start to cut those areas and make them better, make them faster, make them more efficient. Anyone ever read the book? If you have not read this book, go and buy it if you're interested in making your systems better. Okay? It's not a book just for developers. It's a book for the entire business. It's all about making your entire system better, putting logging in place, monitoring in place, better release cycles, better understanding. It's just everything. And a quick summation is like, continuous delivery is a set of practices and principles aimed at building, testing, and releasing software. Continuous delivery brings everyone together in the organization. It's really important. It's a really important point. It's everybody is involved in that job. So why do we have a problem releasing our software? As developers, when we get an idea in our head, it's very hard to shift it. And as I said, we've probably been in a situation where we've had some problems when we're releasing our software, which has meant we've put some red tape in place. We've put extra process in place. Okay, so we've had a failure, and when that failure happens, we sit around a table and we go, how can we not make this failure happen again? I know, we'll put process in place in order to make it harder. And because it's harder, people won't do it. There's lots of common misconceptions around continuous delivery. Lots of them. And they boil down to something as simple as, number one, continuous delivery is only something that startups can achieve. Rubbish. Absolute and utter rubbish. Most software developers, most software professionals work in enterprise IT. The large company I worked for was what I would definitely call enterprise IT. It was probably about 1.5 million lines of ASP.NET and C# code in a single Visual Studio project. It was probably the most monolithic system that I could ever have looked at. But we actually achieved lots of steps in order to make us continuously deliver that software. Number two, continuous delivery only works for Node.js or Ruby or Go developers. Any Java developers here? You can do that. Doesn't matter. You can substitute any language that you want into that statement, and that is then it becomes true. Just because a new fad of development or a new hot technology comes out, and that people associate that you can get started and start to continuously deliver is not actually the case. What is the case is that when you start writing in Node.js or Ruby or Go, you're probably starting a new system. And you're designing your system to be released from the start. And lots of the applications that we work on a day-to-day basis are actually not designed for release. They've just been a code base that's been added to and added to and added to, or a test base that's been added to and added to and added to. Sorry to the consultants, but you can't just hire a consultant to implement continuous delivery. You can't. Continuous delivery is not just right-clicking in Visual Studio and deploying, or IntelliJ, or Eclipse, or whatever IDE you use. And continuous delivery is not as simple as hooking GitHub up to Azure, or AWS, or Heroku. So what happens in software in companies right now is we have silos. We have developers on one side, and we have operations on the other. I can see some people nodding, because they have this in their organization. I had this in my organization. This happens in most organizations. It really does. And you get what's called the wall of confusion. Operations want stability. Developers want change. We love new shiny technologies. We love trying new things. But the operations guys don't, because they're the poor, I nearly swore there, they're the poor people that get woken up in the middle of the night. They're the people that get paged when systems go down. And if you don't know what the difference between the developers and operations are, then DevOps Borat has a really good example. He says, if you're praised for website success, you're a dev, and if you're blamed when the website goes down, you're an op. And what generally happens is software, developers take some software, they throw it over the wall, and the operations people release the software. Okay. And you get a situation where it worked fine in dev, but it's an ops problem now. This is true. Let me ask you a question. If I did not know you, and I walked up to you with a USB stick, and I asked you to plug that USB stick into your laptop, would you? So why would you release software into production that you have no idea what it is? It's a recipe for disaster. By the way, that was the right answer. Never do that. Never do that. But as operations people, why do we just accept the status quo that someone has given us a package of software and we go, yeah, sure, we'll release that. We have no idea what it does. You have absolutely no idea how that's going to act in production. In fact, you could have a very malicious developer who's just been sacked, who has written an Easter egg into the application that will do something stupid like formatting the root partition or deleting the C drive. You just don't know. So this brings in the fact that the revelation here is that if developers and operations became involved in the release process, then it would become a little bit better and a little bit easier. This is not brand new stuff. This is what I would technically have always thought as very straightforward, very simple thinking. But it's not how I used to think. It's not how most companies think. So I'm an infrastructure engineer. I am not a sysadmin. I do not rack and stack. I do not deal with networking. There are people who are much better at that, whose job function is that, who have studied that at university. I am not here to take their job. Infrastructure engineering is not there to take someone's job or automate someone out of the business. It's a case of understanding that there's an area between developers and operations that can ease the pain and that can work between both teams and start to bridge the gap. This is a really good graphic. Okay, this is an image by John Turner, who is like the head of engineering at paddypower.com, okay, which is a betting website in the UK. And he basically has put all of these things down on a piece of paper where he said, as a team, we have to be involved in every single one of these in order to successfully deliver our software. Now, when he says team, he means QA, he means ops, he means devs, he means business people, etc. And he's not saying that the red is for the ops people, and the blue is for the development, and the gray is for QA. He's actually specifically called it a team. But he's put different colors so that you can actually see the different areas of the system and the crossovers that happen. I've since had a couple of conversations. This was in 2014, actually like a year ago this week. And I've since had some conversations with people that think that these areas, which are major crossovers and like cross-cutting concerns, should be much more spread out. They should be much more throughout the system because there are points of the system where everyone needs to be involved. So, for example, unit testing. Unit testing isn't just a development problem. Unit testing is actually, you have to unit test your infrastructure code as well. So there's a whole area of this. I'll just wait until, there you go. And what this led to is when infrastructure engineering shifted, this is my actual experience, infrastructure engineering actually shifted the mistrust from between developers and operations to between the operations and the infrastructure engineers. Because as I said, I'm not here to automate someone out of the job or take someone's job, but the operations, the traditional sysadmins believe that. They believe that I was there to make things more efficient, that we could get rid of them. I was just bolstering their team. So what does an infrastructure engineer do? What do I actually do? I gave this talk for the first time last month, and somebody actually said to me before the talk, I want you to describe what an infrastructure engineer does. And I had to sit around for like a week, actually genuinely sit around for a week and question my colleagues about what I do. And that's not great. But I actually felt that there were some good answers that came out of my colleagues, so I quoted them. I took them. And I'm going to take them because it makes me sound actually quite good, and I'm not. Number one, I provide the ability for development teams to have self-service tools. Okay. Now what that means is I actually create the systems and manage the systems in production that allows developers to actually interact with production. Okay. Let's give you a demo. Oh. Amazing. Somebody's been running a production check for like the last 20 hours. Awesome. So, none of my developers have access to production. Nobody has SSH keys. I'm a very lucky person who works 100% in AWS using Go, so that it's all binaries, and it's all Linux. Okay, I don't have to deal with Windows anymore. This is where my reformed ASP.NET and C# is from. Okay, but there's a free tool called Rundeck, this one right here, and it's out there, and it will actually allow system. Hello, did I just knock this off? No, it's on. So if I actually just do something like hostname, and I do .star, then it will actually go off and it will get all of my production nodes. Okay, this is inside EU West, so this is one of our smallest regions. And it will actually go off and allow me to list all of the nodes in this region. Now from there, you can see everything about them, like their role. So this is like an EC2 tag. Okay, and you can see other tags, whether it's running or whether it's managed by Ansible or an instance ID or what member of an autoscale group is, et cetera, et cetera. So I can then start to break it down and say, I want to run the command that I'm going to run just on the role of admin API. And it will go off and do a live query and actually say, okay, so there's only one box that's an admin API box out there. And then I can actually start to sudo tail -f var log syslog. And if developers want to see what's going on in the box and they want to see what's on the syslog, they run it. And it's actually tailing the log. Nobody needs production access. Production access means people will go and change things. People will go and actually install packages or make changes to configuration. There's no need. It's here. And what this actually allows me to do is fully audit everything that people are doing in the system. And I can see what fails, I can see what passes, I can see jobs that have finished, by who, by when. I can see this one has actually, this is tail in a Docker registry. This one has been running for 12 hours, 47 minutes. And I can actually go and have a look at exactly what's happening for the last 12 hours. So by putting these tools in production, this is one of my primary goals. My primary goal is to allow people to self-service, to allow people to actually put the systems in place. Another one that I do, anyone ever heard of a tool called Terraform? So Terraform is basically an open source tool that allows you to specify your infrastructure in a markup language, in a DSL, and it will actually allow you to manage that infrastructure. So if everyone see the board? Yeah, cool. You know what, let's pipe it through less. So what I can start to do is I can say, with this application stack, which is called the admin API, I want to create a security group in AWS, and I want to allow ingress access on port 443 and port 80, and I want to allow egress access, so full outbound access to everyone. And then I want another security group for the ELB. And then I actually want to create an ELB itself, using some specific subnets and security groups. And then I want listeners. And this basically allows me and allows developers to go off and start to create their own infrastructure. And these types of tools figure a lot more in my other talk. So the main part of my job is to provide the ability for developers to have self-service. They don't want to have to be asking the operations team to build them servers. That takes time. I want them to be able to do it themselves. Number 2, be an evangelist of getting developers to take responsibility for their own system. Who here gets paged? Paged. So when your system goes down in the middle of the night, you get woken up? Everyone in my team does. Unfortunately, that's the way it has to happen. If you put your rubbish system into production, You should be the one to be woken up. That will make things be fixed so much faster. I can guarantee you. I will 100% guarantee you. But that's not what this is about. This is not about getting people woken up. This is about getting the developers to understand that software has to be maintained in production. It has to be. And it's not just one person's job, it's everybody's job. It's everyone who's been involved in the creation of that software to maintain it and look after it and understand how it's working. And then number 3 is I have to take responsibility for the health of the entire system. That's not the individual components. I have to take responsibility for the whole of our AWS infrastructure, for interactions between the systems, making sure that networking between the systems is working, making sure that security groups are there, making sure that our systems are actually secure. Security is a massive part of what I do. And I have another job that runs actually in Rundeck. Come on. I have an entire project in Rundeck called CVE testing, okay? And there are some very well-known exploits out there for SSL and TSL, etc. And I have automated tests that run against every one of our domains, every night. And it will go off and it will actually throw malicious code at our system and tell me if the systems are actually still secure, or if our Nginx configuration is broken, or if somebody has changed a DH param that removes the key from 2048 bits down to 1024, which makes it less secure. We have got the Frig vulnerability test. We have Logjam, which was one recently. We have the Poodle vulnerability. We have Ghost. We have Heartbleed. We have Shellshock. Any time that there's a real vulnerability that comes along, part of my job is to secure the system against that. Not by doing the work, but raising the visibility of that. So I have to take the entire, my job is not on the actual application level, it's much further back. It's the applications, it's the database, it's the networking, it's the security. And I'm not just doing all that work. It's about being the evangelist to make that better. Sounds like a lot like DevOps, right? I love that terminology, that DevOps is about the communication. Because that's what it is. I communicate with all the pieces and all the stakeholders to make our systems better. Really good point of what DevOps is. Okay? DevOps is not about learning each other's job. It's understanding that money is actually made when software is running in production. Can't say it any better. That's what DevOps is right there. It's about us working as a company and as a team in order to deliver software that makes us money. Now, I asked somebody, I tried to be clever the last time I gave this talk, and I actually said to someone, I said, hands up whose company who likes to make money. And everybody except one person put their hand up, and I asked them why, and he said, I work for a not-for-profit. It doesn't matter whether it's a not-for-profit or a commercial company. We all have to make money to survive. We have costs. And the money comes in, fair enough, in a not-for-profit, it offsets, but we actually need to pay people. And you can't pay people unless you have a product. And you can't earn money unless your product is good. ABC, really simple, really simple. We're all part of the same team. We're all part of the same team. It's really, really, really important. And when you can move to using DevOps technology, or DevOps thought processes and better tooling and better processes, you actually get really good results. And Revolution IT and Puppet Labs took, it was like a study, it was a questionnaire, basically to try and understand how people use their systems and how they benefit and what they do in their systems. And apparently, according to the results, and the link is there for the PDF that you can download, and you can have a look at it. Apparently, obviously, high-performing IT teams are more agile. When I say more agile, apparently they can deliver code 30% faster, or 30 times faster, with 50 times less failures. Because they practiced that question that Mary Poppendieck actually asked us. How long does it take us to make a single change, and can we do it on a reliable and repeatable basis? High-performing IT teams can recover faster. If everything is automated, like I just showed you, then it doesn't take long to change. In fact, if I show you so I have a Terraform project. This is my infrastructure project, okay? And I have applications, databases, DNS, IAMs, S3 buckets, and VPC. Okay, not a lot at all. And I have a top-level makefile, so that when I need to check for changes in my infrastructure, I can say make plan full, and it'll actually go off across my entire infrastructure one at a time, and it'll check to make sure that no one has made any changes to my infrastructure. Okay, so that means my entire infrastructure is automated. Great. So what I actually can do I have got what's called terraform.tfrs everywhere, okay? And this basically allows me to set the AWS region that I'm in, or swap between regions. And if I just show you, okay, a lot of what I do is based off this key. Region equals AWS, region equals var.aws region. Okay, this uses my system, and it allows me to change my system and I can actually say at this point, make plan full. And because I've changed my region from EUS 1 to US West 2, it will actually tell me, I had to check that I did a plan there and not an apply. It will actually tell me if there's any changes between each of my environments. And if there's not, it will actually go off and actually give me the results of the change. Let me ZSH reload. Come on. And if there were any changes between any of my environments, it will allow me to fail over. So all I have to do is to change my environment variable to a region that I don't currently use. Okay, so if there's an outage in US West 2 or EUS 1, I can change to US East 1, and it will spin up my entire infrastructure and recover that from that application outage in approximately 6 or 7 minutes. That's all it takes. That includes creating the databases, changing the DNS over. So I can recover from failure in about 7 minutes, which is pretty good. If I were go back to your office on Monday and try and work out what your disaster recovery plan is. Try and work out how you can fail over to other environments. I didn't have one at my last job. Oh, no, I take that back. We did. We had a disaster recovery data center. And the disaster recovery data center didn't have enough capacity for any of our other data centers. Apparently, it was just being used as database backups. So it's important that you can go and that you can understand failover, because failover is very important. And lastly, when you can recover faster and you can actually release code faster, you can actually start to experiment. you can start to understand other areas of making money in your software. When you have less time being spent firefighting and chasing bugs, you can start to apply that time to better and more experimental learning technologies, putting a new technology in place, changing systems around to make them more visually acceptable for users, that allows them to be easier so that you can test them. Can I take advantage of any of these points if I work in a Windows environment? Does anyone work in a Windows environment? You can. You can certainly take advantage. Azure allows you to do this. Terraform has a plugin for Azure that will allow you to do it. It also has a plugin for vSphere, which is a VMware-based tool that allows you to spin up VMs. It doesn't matter what environment you work in. It's all about making a tiny difference and making a tiny change to make it better every single day. Anyone ever heard of the tool Puppet? So, the Puppet Forge, come on. The Puppet Forge is where you, have I not got DNS? What? What? Strange, didn't resolve. So the Forge is a place where people go and put their Puppet modules, okay? Chef has the equivalent, it's called the supermarket. And you can go and look up the chef recipes. But Puppet is a place where it has Windows modules. And I've written quite a few of these Windows modules because I used to work in a Windows environment and I used to use Puppet. But if you go and actually search for Windows, you'll actually find that there's 187 modules that actually work on Windows. Okay, and that's down to things like controlling your firewall, your Active Directory, SQL Server. There is actually a Puppet module that will allow you to manage SQL Server. Okay, just because you're on Windows, it doesn't mean that you're left behind, that you can't take advantage of these things. As I said, it works for everything. Everything. It's really important to get that. There's some great further reading. Absolutely fantastic. If this is the area in which that you're massively interested in, and this is an area in which that you can drive forward. The first book is a book called The Goal, and it was written in the 80s about management of. It was like a factory, okay, and it was basically all around understanding how areas in the factory failed in their delivery, because you got different work centers, etc. That was rewritten in 2012 to be the Phoenix Project, which was then became about an IT infrastructure organization and about the problems in that between marketing and QA and the business, etc. You've got Continuous Delivery book. If you haven't read it, please read it, if this is the area in which you want. And then very recently, a new book came out called Designing Delivery. And it's all about how we should rethink the systems we actually build. Because not just thinking about the actual delivery of systems, but it's all about delivering the value to users. So it's about delivering user-based systems rather than just software. If anybody has any questions, come and chat to me at the end. Okay, I have an hour until the next talk, so I'm more than interested in showing you any other code or anything like that. But hopefully you enjoy the rest of the day, and hopefully there's some other good sessions for you. Thank you all very much.